So this is a typical exam question that we are going to answer, which was written in the June exam from one of the colleges, the schools, I mean, that we are going to focus on. So this is question number 4. Simplify the following. So we're given different types of questions, and these are the questions that we are going to look into, and that's a whole 24 marks. Okay, so let's see how we're supposed to attempt these typical questions. So the first part we are given a, that is c squared plus c squared plus c squared, that is to the exponent of 2. So this is an algebraic expression. Remember, on our algebraic expressions, we talk about like terms. All right, you are supposed to know about like terms, whereby you are supposed to be having the same exponent on the same variable. So if you're given a certain variable, it must be the same, and also it must have the same exponent. All right, the same power. It must have the same power. So this is C, which is the variable that we're talking about, is C, is the same throughout. And also the exponent, this is 2 throughout. So we can add these. All right, so this is same. Like there is a 1 which is invisible. Another one which is invisible. So that is, we are going to add 1 plus 1 plus 1. So that is 1 plus 1, which is 2, plus 1, which is 3. So this is going to give you 3. And do not forget the c to the exponent of 2 that you're given. So you are going to simply add 1 plus 1 plus 1. Okay, so that's the same thing here on 3a minus 2a minus 5a. Again, these are like terms. We have got a to the exponent of 1, a and a. So these are like terms. So you can simply subtract. So in case that you have forgotten these or the application of your directed numbers, because this is simply subtracting 3 minus 2 minus 5. All right. So in case you've forgotten these to subtract, I mean, your directed numbers, you have challenges with directed numbers. The calculator is there as an assistance on that nature. All right. So this is what you're simply going to do. 3 minus 2, then you subtract a 5. You're going to subtract a 5. So this is minus 4. So do not forget that there is supposed to be a on that part. So that's minus 4a. This is going to be minus 4a. All right, number C. We are given again to simplify, that is 3p, but this time it's a product. We are multiplying 3p times, that's a times there. So this here is the same as we are given something like this, 3p times p, like this. This is what it means. So you remember of your exponents there, when the bases are the same, because there's a p and a p, you're simply going to add the exponents. This is 1, this is 1. So you are simply going to add the exponents. So it's going to be 1 plus 1. If the bases are the same, you add the exponents. So 1 plus 1, that's a 2. So that's 3p to the exponent of a 2. All right, so this is what you're supposed to have done on this question. Let's check question D. If you check the D, we are given, this is 6b over 3b, like this. Okay, so you can divide. If you are given fractions, okay, you can divide. If these two are the same, they are just same exponent. All right, if you're just given x over x, you can cancel that. It is just like 2 over 2. 2 into 2 can just divide 2 and 2, they cancel. That's 1 over 1. So it's the same thing. The b and the b cancels, they are the same. All right, so if we divide 6 divided by 3, all right, how many times? Okay, 3 into 6, how many times? That's 2 times. So meaning to say our answer was just going to be a 2. Or if you do not understand your division when it comes to the numbers, just use your calculator. 6 divided by 3, that's going to be a 2. Already you canceled the b and the b. So the answer was just going to remain as a 2. All right, so that was it on number on this part D that we had. Now part E, if you check what you're given here, this is, okay, let us just rewrite this question. 3 times A, okay, then there's a plus there, plus, take note, there's a plus there, then that's 4 times, you're gonna multiply the A, there's also a times there, you're going to also multiply a B, then minus, take note, there's a minus there, then 2 times, there is a times there, times A. Okay. Whenever you see a complicated question like this, where there are so many terms, multiplication, addition, subtraction, what do you think of? You must think of your BODMAS. This is what can help us to solve or to simplify this. To simplify. So you are going to need your BODMAS. We have the brackets, no. Division, no. Multiplication, we move on to the multiplication. Yes, there is a multiplication. These two, they're multiplying together. 3 and 8, take note here, they are separated by a plus. So you move on to another part. Is there a multiplication? Yes, there's a multiplication here. 4 times A times B. Up to this one, it's a multiplication, all this. 4 is multiplying A, is also multiplying B. Then here it's a subtraction. So you are going to leave that and you move on to 2 and A. These two are also multiplying each other. So that is what you're going to have at the end. So you're going to multiply 3 times A. This is the same as there is a 1 here. So 3 times 1, that is going to be 3A. Okay, the same thing here, there's a plus. So we're going to have our plus. Then that's 4 times 1A times 1B. So it's 4 times 1 times 1, which is 4. Then A times B, this is going to give us AB. Take note on that. There is a minus to subtract. So you're going to subtract. What are we subtracting? 2 times A is the same as 2 times 1A. So 2 times 1, that is going to be 2A. But considering that we have got a minus. So once you are at this stage, you have multiplied this. Then at this stage, consider now your like terms, just like what we had before. If you consider this question, it's exactly this part here, 3A minus 2A. These are like terms. You manage to subtract to say 3 minus 1, minus 2, and you get 1A minus 5A, which ended up giving us 4A. So it's the same thing. Look here, 3A and minus 2A. These are like terms. Do not add this to AB here. We cannot add because there is A and B. A and B, there are two terms there. So it's no longer a like term to this one, but these two are like terms. So you're going to focus on these two. All right. You are going to focus on these two, the 3A and the minus 2A. So you simply subtract there. So you're going to simply subtract 3 minus a 2. 3 minus a 2, that's a 1. But do not forget that there is an A. And remember that 1A is same as A. So that is same as A plus 4AB. So you're going to take this part here that is remaining as it is. So we are remaining with what? We are left out with 4AB with a plus. And as you can see, it's a positive. So at this stage, there's nothing that we can do. These are unlike terms. But if here there was a B like this, we are going to add because it's going to be 1 plus this because there is AB, AB. But because of these and these two, they're different, okay? Because there's a B and on this case, we just have A, so we cannot add. This will be our final answer. So that is what you're supposed to have simplified this question. All right, that's 3 marks for that. Let's check F. On F, we are given again to simplify. That's 3 into the bracket of x minus y like this. Minus 2, there's a bracket. That's 2x minus y like this. So in your term 2, they are going to ask you typical questions like these ones, where you just have to expand brackets, collect like terms. Yes, they are going to do ask these questions in your algebra. So you must revise these questions, okay? So remember your distribution when it comes to a bracket. Whenever you see a bracket like what we have here, there is a bracket x minus y. It's a bracket, this one. There is a bracket 2x minus y. So you have to distribute by what is outside the bracket. You multiply by what is outside. What is outside this bracket is 3. So 3 must multiply everything in this bracket. The same thing with this minus 2, the number with the sign, it multiplies everything in this bracket. That is to distribute that. Okay, so let us distribute this. 3 multiplies x. So that's 3 times x, which is 3x. They're the same as 1x. So it's 3 times 1, like I said before. All right, same here. There's minus 1, so it's 3 times minus 1. That's minus 3, but there is a letter, which is the letter y. Okay, so we are done with the 3. The 3 multiplied this also. So the same thing with the minus 2. The minus 2 here multiplies this number here. Minus 2 times 2. That's a minus 4. So that's minus 4, but we've got what? X. The same thing, the minus 2 multiplies the minus, but what is the number there? There is a minus 1. The number is invisible. All right, there's a minus 1 there. So it's minus 2 times minus 1. Remember, minus, minus. If you multiply a negative times a negative, it becomes what? A positive. So minus, minus, that's a positive 2y. Okay, then on this part, there is minus 3x. This one is not affected by any bracket. It is just a single term on its own. It is not affected by anything. What multiplies the bracket is the number in contact with the bracket, the one that is in contact with the bracket. This one is just to be you subtract it at the end. So you expanded the brackets. This is to remove the brackets. Expand. Okay, so you have to expand to remove the brackets. Now you have to collect your like terms. Remember the issue of like terms. We must have the same exponent. Like I said before, you must have the same exponent, same variable. So this is x. So you've got 3x. Are we having another part where there is x and same exponent? Yes, there is also this part of minus 4x. There is also this part of 3x. So if you check properly, you are going to see that we have got the same exponent on these x that we have. So on this part, do not even worry. You can just take your calculator to simplify everything that you are seeing. You just have to focus on the numbers. X is going to remain as it is. So you just focus on the number. This one, 3. So it's a 3. You move on to this one. What is happening? It's minus 4. So that's minus 4. You move on to this one. That's minus 3. So you subtract your calculator is going to give you the answer. That's minus 4. So meaning to say we're going to have minus 4 with what? With x. The same thing on this part of y. There is a y, the part of y and the part of y. So it's minus 3 plus 2. So let's get to our numbers. Minus a 3 like this. Then we add 2 plus 2. So this is minus 1y. So you're supposed to write it as minus 1y like this. But remember that minus 1y is same as minus y. So you can just write as minus 4x minus y like this. It's same as you're given 1x. 1x is same as what? Is same as x. Remember, if the number is 1, it can be ignored just to be left out as if it's not there. All right, same as a minus 1. So that is the idea there. Okay, so this is to simplify. Let us check another question. All right, so this is G. We are given this one. Simplify. Whenever you see fractions like these ones, okay, let me explain it this way. Whenever you see this type of a question, this is how you're going to answer this. So do revise a lot of questions after this. Check for questions like these ones, revise them. Check for questions like these, revise them. Check for questions. There are so many so that you actually understand as much as you can. Okay, so this is it. This is it. Whenever you are given this type of a question, whenever you have this type of a question like this is what you're going to do. There are two terms here on the top. So this is the numerator here of the fraction, the top of our fraction here. There are two terms. This is a term. This is a term. So we are talking about two terms. That's a binomial. So we're talking about a binomial there. Okay, that's a binomial expression. That's binomial like this. Binomial like this. Okay, so we are talking about two terms. Then on this one, it's a single term. That's a monomial. That's a single term. So whenever you have this type of a question, when there are two terms like this and one term, you can separate them. I want you to learn this: A plus B over a C like this. If you're given something like this, okay? Or let us just say A plus B plus C plus, and so on and so on. But there is something that is under here, just a single term. Let's say it's N, it can be C, it can whatever that you want. You can separate this. This can be written as A over N plus B over N. So you must separate that way. That is A over N plus, there's a plus there, B also over the same N. It must be over this same number. So what happens is that when they put a minus here, when they put a minus, all right, it means also this will be a minus. If it is like this now, A minus B, it is going to be the same thing, A over N minus B over N. What is important is that this here is going to affect A, is going to also affect the part of B. So that is what we have here. There is 7B, which is a single term in the denominator. So you're going to separate this. You take this one over this, okay? You divide like that. So that's 14 D squared over 7D. You also take this one like this. That is minus 7D over 7D, just like that. All right. So this can now, if you're at this stage, you are just like what you had on this fraction on D here. Remember how you simplify this one. Because it's a single fraction, you can even divide these. That is how it is now. It's just a single term to a single term. So you can even divide your numbers. 14 divided by 7 or 7 into 14, that is 2. Okay, here it's D into D squared. How many D's do we have here? There are 2, just like D times D. So if you divide by 1D, what's going to happen? You're going to remain with only 1D in the numerator, all right? Or you can even subtract your exponents since you are dividing the bases, which are the same as 2 minus 1, which is D, okay? D to the exponent of 1 is D. Or you can just cancel. This is what I'm trying to say, guys. If you're given something like this, D to the exponent maybe is 3 over a D like this. You just ask yourself, this is 1D. These ones, they are 3. So if I cancel this one, 1, okay, this 1D by 1D, I divide by a D here. It's going to be a 1. So if I divide by a D here, it's like there are 3. Then I divide by 1 into these 3. How many will remain? I'm going to remain with the 2 D's. So these 2 D's, D times D, remember from our exponents, we said the same as D to the exponent of 2. So if these D's are 2, it's just going to be D. So on this one, it was D to the exponent of 2 over a D. So there are 2. This one is 1. So if I cancel this one into these ones, which are 2, there are 2 here. So how many will remain? Only 1D will remain. Okay, that's the idea there. So it can also be like this, d over d squared. So this one, this 1d, this one, I divide by it into these ones, which are 2. I'm going to have a d, but this one, it will be in the denominator. So it's going to be 1 over a d. But this one is going to be d over 1, which is same as 2d, just like 2d over 1, like this. It's just as 2d. Remember, 2 over 1 is same as 2. 3 over 1 is same as 3. So guys, please do revise as many questions, okay? Like I said before. So on this one, I said if the numbers are the same, you can just cancel them, the 7 and the 7, the d and the d, that is going to be a 1. So this will give us 2d minus 1. There's nothing that you can do. At this stage, you're done. At this stage, you'll be done. So that's 2d minus 1 like that, okay? Then let's move on to h. H we are given, this is h, which is it's a product there, x to the exponent of 2. That's this simply means times. That's times 2x to the exponent of 3. Then again times 5x to the exponent of a 4. So that is what it simply means. So when you're given this, remember I said there is a 1 which is just invisible. So you multiply the numbers. You're going to multiply the numbers. 1 times 2 times a 5. You multiply the numbers separately. 1 times 2, that's 2. 2 times 5, that's a 10. But when it comes to these x's here that we have, the part of x, remember your laws of exponents. When the bases are the same, if you are multiplying, maybe it's a to the exponent of m times a to the exponent of n. You add the exponents m plus n. So it's the same thing that we are here, that we are having here. So you're just gonna add these exponents. Is 2, is 3, it's 4. So that's 2 plus 3 plus a 4. So that was going to give us 10 times this x, which is going to be 10x to the exponent of what we add. That is going to be 2 plus 3, which is 5, plus this, that's a 9. Okay, so if you add properly, you're going to have a 9. Just like that. So there's nothing that you can do from there. This is in simplest form. All right, so the same idea on this question number I that we are given, that is 2a to the exponent of 3. That's a times that you're given there. So you're multiplying 3ab squared, all right? Then in a bracket, so there's a bracket minus 3a to the exponent of 2, b to the exponent of 2. All right, so in this first bracket, there's nothing that you're going to do. Just multiply these numbers because just like the previous case that we had, going to multiply the 2 and the 3, that is going to give us 6. The bases which are the same, there's a here, but this is a to the exponent of what? Of 1. This is a to the exponent of 1. So you multiply a to the exponent of 3 times a to the exponent of 1. You add the exponents. So that will be a to the exponent 3 plus 1, which is a 4. Okay, then b is not affected because we do not have a b here. So the b is going to remain as it is, b to the exponent of a 2. So the first part, we are going to have 6a to the exponent of 4, b to the exponent of 2. Okay, so the bracket is done. Then you're going to multiply to the answer that we are going to have from this bracket, which is being raised to the exponent of a 2. Remember, I talked about this, a negative when raised to an even number. If it is an even exponent, it will change to be a positive number. So this negative to the exponent 2 is an even number, so it will be a positive. Okay, so you raise 3 to the exponent of 2. So it was just minus 3 to the exponent of 2 like this. So it's a negative to the exponent of 2, or simply minus 3 times minus 3. Minus 3 times minus 3, that's what? A positive 9. Negative times negative, that's a positive. So that was going to be positive 9. But the same exponent, this one, is going to affect also a. So it's a squared to the exponent of 2. A to the exponent of 2 to the exponent of 2. Remember the idea of an exponent to an exponent. You multiply them. 2 times 2, that is going to be a 4. So this is a to the exponent of a 4. Then the b also will be raised to the exponent of a 2. Everything that you are seeing inside the bracket must be raised to this exponent that is outside of the bracket. After that, this question is just the same now, just like this question that we had before, where it was a product, you have to multiply, consider the bases which are the same, you add the exponents. This is where we are at this stage. So you simply have to multiply the numbers, the 6 and the 9. That is going to give us 54 if you multiply. Then you consider the bases which are the same. So in this case, I'm considering the A, this one, the base of A. There's also the base of A here. So if the bases are the same, we said we are going to add the exponents. So that is A, this one, to the exponent of 4 plus this one, which is a 4. So 4 plus 4, that's 8. So that was going to give us A to the exponent of 8. You do the same thing on the base of b. In this case, if you check, there's another base that we have, which is the base of b. The base of b in this case raised to the exponent of 2, and this one to the exponent of 2. So you also add 2 plus 2. That's a 4. So if the bases are the same and you are multiplying, you add the exponents. You add the powers. 4 plus 4 on this A. Then on this b, you consider b on its own, you add the exponents 2 plus 2, which is a 4. So that was going to give us 54a to the exponent of 8, b to the exponent of 4 as our final answer. So please do so to just work also again to redo these questions to see if you are understanding and also in the right place. All right, then another part. So this was actually 4 marks, the previous question. Then this one, 4 marks again. Then on this J, we are given, if you consider that's 5p to the exponent of 3 in a bracket, into the bracket of p to the exponent of 4, q to the exponent of 3, to the exponent of 2. So already I have talked about these laws. So we are going to simply apply. The first bracket is raised to which exponent? The exponent is invisible, so it's just to the exponent of 1. So there's nothing there. It's just going to remain as it is. So that's 5p to the exponent of 3. All right. Then the second bracket, now it is raised to the exponent of 2. This bracket that we are seeing, the whole of this bracket, everything that we are seeing is raised to the exponent of 2. Remember, I said when it is like this, it is going to be an exponent to an exponent. So meaning to say, we are going to have p to the exponent of 4 times 2. You multiply, that's 8. Then the same on q, an exponent to an exponent. So that's q to the exponent of 3 times 2, which is 6. The exponent affects everything, all right? The power that you're given there affects everything. And as this power affects everything, you must also consider to say there is also an exponent. So it's exponent times exponent, all right? So this whole part is over 10p q to the exponent of 3. There's nothing that we can do for now. Okay, let's simplify further. From the numerator, we can see we are back to the bases, which are the same when we are multiplying. So we can consider our laws again. 5 times 1, that is just going to be a 5. So I said if you're multiplying the bases, which are the same, what are you going to do? You add the exponents, that part of p. So this will be p to the exponent of 3 plus 8, which is 11. Then there is q to the exponent of 6, everything over 10. P to the exponent, p, just p here, and that's q to the exponent of 3. So that's the denominator in this case is just going to remain as it is. So if you're to consider, yes, you can divide these, or you can use the laws of exponents if you're dividing, all right, which is fine. Or you can consider what I said previously. Okay, so you're just going to divide 5 into 5, because 5 and 10, you can see that this can be divided. 5, that's 1, into 10, that's a 2. So here you're just going to ask yourself, yeah, this question. Remember what I said? there is only one P here. This is P. These ones, they are 11 P's. So it's like there are 11, like P times P times P. There are 11 of them. So if you just divide by this one, take this one, you divide it into these ones, which are 11. How many P's are you going to remain with? You are going to remain with 10 P's. Remember, there were 11, and you just remove one from there. Okay? So it's the same thing with this Q. There are 3 here. Here there are 6. So if we divide these 3 into these ones, which are 6, how many will remain? Will remain with 3 Q's there. So that's Q to the exponent of 3. So you can just write as 1 times P to the exponent of 10, which is P to the exponent of 10 times Q to the exponent of 3, everything over. In the denominator, we are left with the 2 times 1. You multiply 2 times 1, just a 2 there. Just like that. So these are your questions that they are going to give you something like this in these June exams that we are having, which is going to be very, very soon. So please do so to revise, like I said, as many questions after this, follow up as many questions as you can.